All right, we're now looking at target 7D, last target for this unit. So, our last target is kind of putting everything we've been doing with SOHCAHTOA and Pythagorean's theorem together for real-world problems. So I want to solve for missing sides and angles of a right triangle. So, I can solve for the missing side length of a right triangle by setting up a trigonometric equation. So we're going to start looking at what the sine of angles are. So our calculator can help us with these. Sine of 45 degrees, cosine of 82, tangent of 53. We can type these in our calculator. So your trig ratios and our inverse trig ratios, which we're going to look at in our next video, are all here under this menu. For some reason it's not. Okay, so you can see all of them there. Before we do anything, make sure go to Doc and go to 7, which is Settings and Status, Document Settings. Under Angle, if you see here that it says radian, you need to change that to degree. Okay? And press Make Default so that you don't have to change it again. I'm going to hopefully have all the calculators changed, but especially if you're using your computer, you'll have to do that for the first time. Okay, so that's Settings. All right, so the first thing we want to find is the sine of 45 degrees. So all I'm going to do is go under my trig menu. Ooh. Sorry, it just started jumping. Forgot it does that. Okay. Sine of 45. I don't have to type degrees or anything. Okay, so sine of 45. And I get 0.707. The sine of 45 is. Next one, cosine of 82. Again, I can just type that in my trig. Cosine is the second one. I get 0.139. And then my last one, I should look what the number is, tangent of 53. 1.327. So if you have a different calculator than TI Inspire, all these trig ratios are on there as well, even if it's just one of the little ones. So if you have trouble locating it, please just let me know and I can help you out. All right, so let's look at an example. So we're going to be solving for missing sides of a triangle. There's two things we know how to do to solve. We already know how to use Pythagorean theorem, and then our new one is going to be using trig ratios. So when do I use which one? We're going to use Pythagorean theorem when I already have two sides. I'm going to use trig ratios when I only have one side. So if we look at our first example, I only have one side, so I'm going to be using trig ratios. So for using trig ratios, the first thing I need to do is find my angle. Right, there's my given angle. And I'm still going to start by labeling my sides. We're still using, right, trig ratios means we're using SOHCAHTOA. Remember, what I'm looking for is this x. So I have my hypotenuse, I have the opposite side, and I have the adjacent side. Now I want to decide what trig ratio am I going to be using. Well, where do I have things, I guess, is the best way. I have my variable at O, and I have the number I already know at A. Don't really care about the hypotenuse in this case. So, my trig ratio that uses O and A is TOA, right? Tangent is opposite over adjacent. So I'm going to be using the tangent of theta equals opposite over adjacent. You need that angle there. A lot of people will just leave it off. They'll just say tangent equals opposite over adjacent. Can't do that. You have to have the angle there because I know what that angle is. I'm plugging that in. Tangent of 22 degrees, that's my angle, equals opposite, which is x, over adjacent, which is 5. Okay? the next thing we're going to do, our next step is to always put this over 1 and then just cross multiply. So I have 1 times x, which is just x, equals 5 times the tangent of 22 degrees. Now, x is by itself. This is just going in my calculator. Okay. So I'm just putting that in my calculator. 5 times the tangent of 22 degrees. So I have 5 times my trig ratios, tangent of 22. And I get about 2. We'll round to a nice number. So that missing side length is 2. All right, looking at example 2, this is just Pythagorean's theorem. All right, I have a side here and a side here. So I'm going to just be using a squared plus b squared equals c squared. So I have 2 squared plus 5 squared equals c squared. 2 squared is 4 plus 5 squared is 25 equals c squared. Adding those, I get 29 equals c squared. We'll take the square root, and c equals the square root of 29 is 5.4. And that's it. All right, looking at example 3, I have just one side that I know. Right? So for this one, again, this is a trig ratio problem. So here's my angle. I have my hypotenuse, the opposite side, and my adjacent side. What do I have to use? I have to use the number, and I have to use the variable. We don't care about the opposite side. So cosine uses adjacent and hypotenuse, right? So the cosine of theta equals adjacent over hypotenuse. The cosine of 37 degrees equals 11 over x. Again, I'm going to put my angle over 1 and cross multiply. So I have x times cosine of 37 degrees equals 1 times 11, which is 11. This one's a little bit different, right? My x still has something with it. My x is being multiplied by the cosine of 37. So my last step that I have to do for this problem is divide by cosine of 37. So x equals, and then what is 11 divided by the cosine of 37? I'm just going to type it in. And I get 13.8, we'll round to. Okay, example 4. Again, example 4 is another one where I only have one side given to me. All right, so this is another one where we're going to use our trig ratios. So we have this 74-degree angle. We have our hypotenuse, our opposite side where x is, and our adjacent side. What sides do I need in my problem? I need my variable, and I need the number I have. Adjacent doesn't have anything next to it, so I'm not going to use that one. Okay? And then this is going to be a sine problem, because sine uses the opposite and the hypotenuse side. Okay? So sine of theta equals opposite over hypotenuse. So sine of 74 degrees equals, my opposite side is where my variable is, over my hypotenuse, which is 12. Okay. So like every other problem when we're solving trig ratios, I then will put my trig ratio over 1, and I'm going to cross multiply. So I have 1 times x, which is x, equals 12 times the sine of 74 degrees. It's not a 7, 74. So 12 times the sine of 74, I'm just going to type that in my calculator. So 12 times, in my trig ratios, sine of 74. And we get 11.5. Looking at example 5. So this is another one where I have 2 sides. Okay? So again, this is just going back to target A where I have Pythagorean's theorem. Okay, so I'm just going to use a squared plus b squared equals c squared. So, right, these are a and b and I don't know c. So I have 3 squared plus 10 squared equals c squared. So 9 plus 100. These are on the same side, so I'm just adding them together. And then my last step is to take the square root. The square root of 109 is 10.4. Those are nice and easy if you're given 2 sides. Example 6, I'm only given 1 side of my triangle. Right. So again, looking at my angle, I want to look at what I have. So I have the opposite here, hypotenuse is here, that's where x is, and my adjacent side. So what do I need to use? I need to use my opposite side, and I need to use my hypotenuse. So again, this is going to be another sine, right? The so part of SOHCAHTOA. So sine of theta equals opposite over hypotenuse. My angle is 36. Sine of 36 equals opposite is 7 over hypotenuse, which is x. And like our other problems, once we have our equation set up, we just put the trig ratio over 1 and cross multiply. So I have x times the sine of 36 equals 7 times 1, which is 7. And then, right, since it's multiplication, I'm going to try and move this up a little bit, see if it will let me write. Since it's multiplication, I'm going to do the opposite. I'm going to divide by the sine of 36 on both sides. So x equals, and then I'm just doing 7 divided by the sine of 36 in my calculator. So 7 divided by trig, the sine of 36. And I get 11.9. All right, that is it for solving for these sides. Go ahead and work on activity D1.